In this video, we are going to look at alkanes, and in our previous video, we had a look at the basic introduction to organic chemistry. So if you haven't had a look at that video, please you can check it out if at all this is your first time to study organic chemistry. When you look at alkanes, alkanes are kind of the simplest organic compounds, and we had seen that organic compounds mainly contain carbons. However, alkanes are under a group known as the hydrocarbons. When we look at hydrocarbons, we had seen that they contain carbon and hydrogen atoms only. So we are going to expect only carbon and hydrogen under the alkanes. However, one thing to note about the alkanes is that these alkanes will only contain single covalent bonds. So in our compounds of alkanes, we are going to see only single covalent bonds. Why do we say single covalent bonds? Because we also have scenarios where we might have double bonds or triple bonds. But under alkanes, we shall have single covalent bonds. That is to say, between carbon, and also between carbon and hydrogen. Remember, this dash here shows a covalent bond, where we have the sharing of two electrons. So when you look at our alkanes, we normally have to be able to identify how the ratio of carbon to hydrogen will alternate in the compound. So we have a general formula for alkanes that can help us identify how we can obtain a given alkane. So when you look at the general formula of alkanes, it is CN H2N plus 2, and in this case N, yes, plus 2, this is plus 2. In this case, our value of N is a whole number starting from 1, 2, 3 and so on for the successive members in this kind of group or family. So when you look at the alkanes, we shall always be using this general formula CN H2N plus 2 to be able to come up with a general way of obtaining a given alkane basing on the value of N. And if you are to check very well this N, it will mean that the value of N is always equal to the number of carbon atoms from the formula. So N is also equal to the number of carbon atoms. So let us have a look at some of the alkanes that we can get when we use this general formula of alkanes. As we have seen, the general formula for our alkanes is CN H2N plus 2. But remember, the N, 2N plus 2, all these are subscripts. So let's have a scenario where our value of N is equal to 1, because these alkanes will have different chains of carbon atoms. So for the first case, if at all our carbon atoms are equal to 1, for N is equal to 1, because we said N is also the number of carbon atoms. So for N is equal to 1, we shall substitute the value of N in our general formula. We shall have C1 H2 times 1 plus 2, and then we shall obtain C1 H2 times 1 is 2 plus 2, which is 4, CH4. But we can ignore this one because it's 1. Even if you don't write it, it means it is 1. So we shall have CH4, and we shall have the simplest organic compound, or the simplest hydrocarbon, or the simplest alkane, and we shall later realize that this is known as methane. So when you look at this structure of methane, it will appear like this. We shall have our carbon at the center, and it will be bonded to 4 other hydrogen atoms by strong covalent bonds. Remember, we said covalent bonds are those bonds that involve the sharing of a pair of electrons. However, this is a two-dimensional appearance. In 3-dimension, it will have a different kind of appearance. So you can feel free to try and look for the 3-dimensional structure of methane. But it will appear something like this. Have our hydrogen, our carbon, hydrogen. So you can have this other carbon, this other hydrogen atom going into the screen, and then we can also have our hydrogen. So in 3D, it takes up what we call a tetrahedral structure. Tetrahedral structure, just like that found in diamond. So here we have our methane, CH4. Here we have our displayed formula. Displayed formula. So a displayed formula is a formula that will show you the bonding of the atoms. As you can see here, we have the bond. So this is the bonding that is being displayed. So a displayed formula will show us the bonding. While here we may be having our molecular formula, as we shall see later on what a molecular formula is all about. Molecular formula. So for n is equal to 1, we obtain our first alkane as methane having CH4. Let us have a look at a different alkane where n is equal to 2, and we see what we can obtain. So for n is equal to 2, still we shall use our general formula for alkanes, which is Cn H2n plus 2. On substituting, we shall have C2 H2 times 2 plus 2. We shall have C2 H2 times 2 is 4 plus 2, which is 6. So this is the second alkane. So when you look at the second alkane, it will have its displayed formula appearing like this. Remember, displayed formula is one that shows how the bonds are bonded in the compound. So displayed formula, or the display formula. We shall have our 2 carbon atoms. So I'll put 1, 2. And one thing we said about alkanes is that we only have single bonds, and we should always have a bond between carbon and carbon. The carbon atoms must be at least attached to one other carbon atom. So if you look at these 2 carbon atoms present in this formula here, C2, we have the 2 carbon atoms, and then we have them here 1, 2. So we shall realize that we have to form a bond between these 2 carbon atoms, and it should be a single bond, which is represented by our dash. And then we have 6 hydrogen atoms left. Now remember, carbon has the electronic configuration 2, 4, where we have 4 electrons in the outermost energy level. As such, it will need 4 more covalent bonds, so as it can have a total of 8 electrons in its outermost energy level, so as to be stable, to follow the octet rule. So these 6 hydrogen atoms will be distributed equally, so that each carbon atom can actually have 3 hydrogen atoms attached to it, so that each of them in the end has 4 bonds, 4 covalent bonds, or 4 single covalent bonds. So this is carbon atom 1 and this is carbon atom 2, each of them having 4 covalent bonds. Let's look at carbon atom 1. This is 1 bond, this is 2, this is 3, and that is 4. So this is the displayed formula. However, we can write a condensed displayed or condensed structural formula of the same compound C2H6 as follows, but we shall follow the same principle. Starting from this region, in this region we have 1 carbon atom attached to 3 hydrogen atoms, so we shall write it like this: CH3 And then you have the second carbon atom, and it's also attached to 3 other hydrogen atoms, CH3. So this is what we call the condensed structural formula, or just the structural formula of the alkane whose N value is equal to 3. Structural formula. Yes, let us look at how we name these alkanes next. So when naming hydrocarbons, of which our alkanes are part of them, we shall realize that we shall use two things. When we are naming the hydrocarbons, let us say naming alkanes, because currently we are naming alkanes. One thing to note is that all alkanes will have what we call a name ending. All alkanes will have a name ending because they are compounds or members of the same family, so they'll have a similar name ending, and this name ending will be ANE, coming from the name alkanes. So ANE will be our name ending. So all alkanes, when we are naming them, we shall have that general naming ANE. However, we shall always use some prefix or a group of letters that can be placed in front of the name depending on the value of N. So the prefix will depend on the value of N in our general formula for the alkanes, which is CN H2N plus 2. So for N is equal to 1, let us say our N, we can have 1, 2, 3, 4, and so on. So for the N value is equal to 1, our prefix will be, for N is equal to 1, we shall have meth. For N is equal to 2, we shall have eth. For N is equal to 3, we shall have prop. For N is equal to 4, we shall have but. Now, since we have said the name ending for alkanes is ANE, if at all we want to have our first, or to name our first alkane whose value of N is 1, we shall just add ANE to methane, to meth, then we shall have the name methane. As you can remember, it had a general molecular formula of CH4, where we had an invisible one between C and H. So for the rest, eth, where N is equal to 2, we shall have ethane as the name of the compound, and this will be, like we have seen previously, it will be C2. 2 times 2 is 4, 4 plus 2 is 6, C2H6. If at all the value of N is equal to 3, that is to say if the number of carbon atoms are 3, we shall have propane, which will be C3. 3 times 2 is 6, 6 plus 2 is 8, so we shall have C3H8. And then butane. Yes, you can feel free and pause the video and see how you can write the molecular formula of butane. This is molecular formula. So we shall have C4. 4 times 2 is 8. 8 times plus 2 is 10. 4H10. So these are the names for the first 4 alkanes: methane, ethane, propane, and butane. They have the same name ending, ANE. They all contain only single covalent bonds. And maybe we can have a sketch of our displayed formula for the value of N is equal to 3. So we shall have our displayed formula here. So for N is equal to 3. So for N is equal to 3, we shall have propane. So we are going to sketch how it could look like. So we shall have our 3 carbon atoms, each bonded to at least 1 carbon atom. And then we shall be left with our 8 hydrogen atoms. So when you look at this first carbon atom, you realize that it only has 1 bond, this one here. So we shall have to give it more 3 for carbon to be stable. So we shall give it 1, 2, 3. So all carbon atoms at the end of a chain will always have 3 hydrogen atoms attached to them. So the same applies to this last carbon atom. And as of now, we shall be having 6 hydrogen atoms attached, left with 2, and this carbon atom already has 2 bonds, so if we give it more 2 to make 4, then we shall have all the 8. And this will be the displayed formula for propane. Yes, let us stop here in the meantime. If you have a question concerning alkanes, please, you can leave it in the comment section below. However, we shall have some detailed chemical properties of alkanes, maybe combustion of alkanes, and so on in our separate videos to come. See you next time.